Can our feelings of stress and anxiety originate from our skeleton? Yes, it can. And this can give us a new target to treat anxiety and stress disorders. Tune in for all the details only here on the People Scientist podcast. Listening to The People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, everyone, and welcome back to the People Scientist podcast for episode 77, where every week I arm us with some scientific evidence so we can all be a little bit smarter and healthier every week. How are you doing today? I hope your day is going well and that I can bring some interesting information your way. So this month, I wanted to do some fall or Halloween-themed topics. Last week in episode 76, I spoke about the clinical evidence of cinnamon and how scientists conclude through many clinical trials that daily intake of cinnamon as low as 1/3 of a teaspoon may have benefit for blood sugar and triglyceride levels. In line with themes of fall and Halloween, I wanted to do a bit of a spooky episode, and I came across a really interesting study published last year about how our fear response can originate in our bones or our skeleton. What a perfect episode for this month, hey? So buckle in for this very interesting episode. So as we always do, let's start off with some core takeaways. Normally when we think of our fear or stress response or our flight or fight response, we think of adrenaline and the adrenal glands. However, this recent study for the first time illustrates how fear and the stress response can actually originate from our skeleton as well. Now, there is a particular protein that gets secreted into our blood circulation from our bones upon a stressful circumstance. This is an important finding as it adds to the foundation of knowledge in regard to what regulates our feelings of stress and anxiety. As a result, this new information gives us a completely new target for anxiety and stress treatment. For example, exercise and weight-bearing exercise activates cells in our bones. And a lot of research supports how regular exercise can confer resilience to stress and anxiety. And our skeleton may be a mechanism behind how that happens. Cool, isn't it? Now, let's get into those scientific details. I love to talk about how our bodies work, which is why I got my PhD in physiology. I find that when we can understand how our body and brain works, it can be very empowering. For instance, one of the examples I love to give about how our physiology can be empowering is how previously I've shared with you how our brain responds to alcohol. How alcohol suppresses the activity of our stress and anxiety brain regions. That's why we may feel less stressed when we drink alcohol. Then when the alcohol clears from our system and we wake up the next morning, those same brain regions may rebound and exhibit some hyper-excitability, making us feel temporarily more anxious than normal. Now, knowing that information, how our brain works, can empower us to understand why we are feeling a certain way. Can also help us to make educated, healthy lifestyle choices. For example, if someone is battling with anxiety, then reducing or eliminating alcohol intake may be difficult in the beginning, but very likely to help in the long term. So today I'm going to give a bit of background on our fear and stress response, and hopefully this can empower us to make some good lifestyle choices. It has been understood for many years that certain organs, like the adrenal glands that sit atop of our kidneys, release certain hormones like adrenaline into our bloodstream to induce that physiological stress response, which is increased heart rate, blood vessel constriction, increased blood glucose levels to provide energy, and increased awareness and attention. Certain brain regions like the locus coeruleus that sits near the back of our brain also plays a very important role in that stress response. For example, scientists have looked at the activity of different brain regions in individuals living with post-traumatic stress disorder, or PTSD. In the journal Biological Psychiatry in 2018, scientists published that the locus coeruleus of the brain was more active in individuals living with PTSD, and that this may in part explain the increased stress and anxiety that they experience. For example, the dean of Mount Sinai here, Dennis Charney, co-authored a review this year in the journal Brain and Neuroscience Advances to explain how the locus coeruleus is an important brain region in anxiety disorders due to its role in stress. But why does that information matter? Well, it matters because now it gives us a target. Anything that can impact the locus coeruleus then means that it may impact a contributor to anxiety and stress. So we may target the locus coeruleus as a treatment for stress or anxiety. My brother actually sent me a really interesting study today that fits perfectly with this topic, as a study was just published in the Journal of Neuroscience this past week by Tillage and colleagues that explains how exercise may help with resilience against stress. The scientists illustrated that a particular protein called galanin in the locus coeruleus of the brain can be directly impacted by exercise in rodents, and that galanin was necessary for the ability of exercise to impart resilience. This study adds to the foundation of knowledge that exercise may help us cope with stress. In episode 46, I spoke in detail how exercise, or our body's movement, may promote mental well-being by acting on certain brain regions too. Another study that I'm going to focus on today adds to that body of knowledge on stress and anxiety. As I mentioned earlier in this episode, we thought that stress and anxiety were primarily controlled by our adrenal glands, the locus coeruleus of our brain, and the hormones noradrenaline and adrenaline. But a study last year suggests that our fear and stress response may in fact originate in our bones. Again, this is important to learn because now we can study our skeleton or our bones as a target for stress and anxiety. So let's go through this study, shall we? This study was published in the journal Cell Metabolism by Berger and colleagues in 2019. Our skeleton or our bones have traditionally been thought of simply as a storage of minerals to act as the scaffold to provide structure to our body and to facilitate movement. However, the scientists in this study propose that our skeleton does so much more. The scientists started out by recruiting 20 people, and they asked the participants to perform a task that normally incites an anxiety or a large stress response in many people. Can you guess what the scientists asked them to do? Public speak. Does public speaking make you feel anxious or stressed? Even though I personally have become comfortable with public speaking, I think there will always be a little bit of a stressful feeling involved that will never go away. So in this study, the 20 individuals had to give a 10-minute speech that was evaluated in front of a group of people. Blood samples were taken before the speech, immediately after, and 30 minutes after the speech. And the scientists measured the participants' blood for particular molecules that come from our bones. The scientists noted a large spike in a peptide called osteocalcin. Now, osteocalcin previously was thought to only play a role in binding the minerals in our bones. It is produced by the osteoblasts in our bones and is a marker for bone formation, meaning the higher the levels circulating in our blood tend to mean our bones are turning over and mineralizing. But this study suggests that osteocalcin could be related to our stress response too, that it does so much more than just promote the mineralization of our bones. So the scientists investigated this in mice and rats in a more controlled setting to see if this held true. The scientists wanted to induce a stress response in the mice by exposing them to a scent of a predator. In this scenario, it was a component of fox urine. The scientists noted that osteocalcin increased dramatically in the blood samples of the mice following their exposure to the scent of the predator. Now, I always like to bring in neuroscience whenever possible. So here is some brain science. The scientists realized that a particular brain region was necessary for this response to occur. Can you guess which brain region? I spoke about this region of the brain quite a bit in episode 57. It is the amygdala. The amygdala of our brain is an archaic brain region involved in our emotional responses, our fear and stress responses. In clinical studies where people had their brains scanned using fMRI, while shown fearful images or movies, the amygdala was powerfully activated. Well, in this study, if the scientists inhibited the amygdala in mice, osteocalcin did not increase in the blood. This suggests the amygdala is necessary for the fear response in our bones. What the scientists realized was osteocalcin did not induce a fear response by increasing our fight or flight response directly, but it did so by blocking our relaxation and digesting response. So let's use an analogy to explain this. Imagine you are driving a car, and you're looking in your rearview mirror and you see a car coming from behind rather quickly. So you react by wanting to speed up your car to get out of the way. So your body can respond to this stressor to move the car in two ways. You can either choose to step on the gas, or you could take your foot off the brake. The fear response in our bones is like taking our foot off the brake. Osteocalcin from our bones inhibits our parasympathetic system, which is like the brake pedal, which is the system in our body that opposes our sympathetic or stress response system. The parasympathetic and sympathetic system are in balance with one another to regulate our stress and fear, and in general, a lot of functions in our body. These two systems need to be in balance for our body to function properly. Likewise, the gas pedal and brake pedal in our car need to also be in balance with each other in order for our car to run properly. Osteocalcin is one of those components in our bones that regulates this. So now that we have this new knowledge that osteocalcin from our bones plays a role in the stress and anxiety response in concert with the amygdala of our brain, what can we do with this information? Well, how can we target our bones or our skeleton? We can go back to the topic of exercise. Our bones are obviously required for our movement, and we know certain cells in our bones can be activated with impact or weight-bearing exercises. So now the question we have is, can exercise impart resilience against stress because of its actions on our skeleton? No one has investigated that yet, but I think it is certainly possible. We know that osteocalcin levels can increase in our blood following exercise. So perhaps regular exercise can somewhat desensitize our bones to that stress response and allow our body to become resilient to environmental stressors. For example, let's go back to the topic of public speaking. The first time you may give a talk is likely to be the most stressful or nerve-wracking experience because you're not used to giving a public speech. But if after years of public speaking, you're very likely to become far more comfortable with the experience, and it does not incite such a stressful response. That is in part how exercise may make us more resilient. Exercise itself is somewhat of a stressor, but a healthy stressor. And the more often we exercise, the more our body gets used to that stressor. And so what I propose, which no one has investigated yet, but what I propose is that exercise increases osteocalcin, yes, but that is one of the mechanisms by which it makes us more resilient against that stressor. What I really like about this research is how it really just opens the door for so many more clinical trials to promote mental well-being and to reduce anxiety, generalized anxiety disorder or PTSD. For example, can we look at medications or natural health products that can target the bones in order to promote mental well-being? For example, we know that vitamin D targets osteocalcin and our bones, and we also know that vitamin D is important for mental well-being and reducing the risk or symptoms of depression. Is part of that because of its impact on osteocalcin and our bones? It's very possible, and this research would suggest, yes, it's likely. Another future direction to come out of this research could be to understand what in our lifestyle impacts osteocalcin levels. For example, we know that drinking alcohol can cause a reduction in osteocalcin levels by about 10% on average, which could make sense because we know alcohol tends to reduce stress and anxiety temporarily while we are consuming alcohol. However, what I bet happens is a rebound effect that causes an increase in osteocalcin and an increase in anxiety, as we know alcohol to have that rebound effect on anxiety and stress. See, this is the power that understanding our body holds. Now that we understand our stress or fear response can also originate from our bones, it has opened up the door to many new possibilities for stress or anxiety treatment. And the fact that we know exercise impacts our skeletal system can give us more information or support for the fact that exercise can impart resilience against stress and to promote mental health. And I can't wait to see what the future research holds in the next couple of years to see if we can somehow target our skeletal system or our bones to promote mental health and mental well-being. If I see any new studies on this topic, I will make sure to update all of you. So that is a wrap, my People Scientist Army, for episode 77 on how our fear and anxiety can originate from our skeleton. For many, many years, we thought that our stress and anxiety response originated from our adrenal glands and the hormone adrenaline. However, this study for the first time illustrates how our skeleton releases a protein called osteocalcin to induce a stress-fear response. And it does so by taking our foot off of the brake, so to speak, by inhibiting our parasympathetic system, and thus allowing the stress response to overtake our relaxation response. This information is so important because now it opens the door to new therapies, for example, for PTSD and anxiety-related disorders. For example, there's quite a bit of evidence on how regular exercise can impart resilience to stress and promote mental well-being. We know some of the mechanisms by how exercise may impart this benefit, as I described in episode 46, but perhaps another way exercise has this benefit against stress is by targeting our skeleton through movement and weight-bearing exercise. So I hope this episode was interesting and thought-provoking for all of you. Please make sure to follow me on social media where I share some extra information on the week's topic every week. And a few of you have asked if you could donate to the podcast to help keep it going, and I appreciate that so much. So I have a Patreon link and my Venmo ID in the description box to this episode if you feel like buying me a coffee to say thanks for the information. If you are listening on Apple Podcasts, would you mind taking a moment to give me a quick rating or review so I can find out if you are enjoying the episodes and so that others can see if this show is worth a listen. I hope you all have a wonderful and healthy week, and I look forward to meeting you back here the same time and same place next week for another episode on the People Scientist Podcast. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.